morning, class. It's Thursday, April the 23rd. Our next to last class meeting. I have decided that we're going to have a take-home exam. This was not an easy decision. It's not what I was expecting to happen. I said several times I thought we would have a proctored exam, but the way things have played out, this seems to be the least bad decision. So you'll get incidentally, the other in-class section of finite math is also doing a take-home exam, so we're in agreement about that. Okay, let's see, other announcements. I have a lot of work to do this weekend. I have to get your exam ready. I have to get another video uploaded, your second test graded, your fifth quiz graded. All of that has to happen this weekend. All right, so let's continue with what we were discussing on Tuesday. This was the example of matrix multiplication that we had at the end of that video. So on the left we have a 2 by 3 matrix, 2 rows, 3 columns. On the right we have a 3 by 2. We mentioned that to multiply matrices, these numbers on the inside have to be equal, and if they are, the size of the answer, the dimensions of the answer is specified by the outer number. What I've done here is I've interchanged the two matrices. So now the left one is 3 by 2, the right one is 2 by 3. We can still multiply, but the answer is going to be 3 by 3. It would be a good idea for you to, at some point, freeze the video here and do this calculation to make sure you understand how matrix multiplication goes. Let's just do one or two quick calculations. So for instance, I'll just pick an entry at random here. This is in the middle row in the left column, so we multiply the middle row in the left column. 3 times 2 is 6, negative 1 times 1 is negative 1. So we add the numbers 6 and negative 1 and we get 5. Here's another calculation. Bottom row left column. So 0 times 3 is 0, 5 times 4 is 20. So we add the numbers 0 and 20. Okay. Now, the next thing is how to invert a matrix. That's what we're working toward. So I first have to tell you about identity matrices. So here are the first few identity matrices. So there's the 1 by 1 identity. Here's the 2 by 2 identity. Here's the 3 by 3 identity. Four by 4. So the notation for this, this is I1, I2, I3, I4. And this is the matrix, I forget what we call this, maybe it was A. Why are they called identity matrices? Well, the reason is, if you multiply a matrix by one of these, you just get that other matrix back. So let's demonstrate. Okay, now I can multiply either on the left or on the right. Now this, of course, is 2 by 3. So if I want to multiply on the left by an identity matrix, it had better be 2 by 2. And so these are equal. We can multiply. The answer is going to be 2 by 3. You can check that this product is just this matrix. Upper left, 3 plus 0. Upper middle, so it's -1 plus 0. Upper right, 2 plus 0. Lower left, lower row, left column, 0 plus 4. So you see what's happening. This matrix is the same as this one. And if you do it on the other side, you need I3. So we have 2 by 2, 2 by 3, 3 by 3. These are equal. The answer is going to be 2 by 3. Upper left is 3 plus 0 plus 0. Upper middle is 0 plus -1 plus 0. You get the idea, I hope. So these identity matrices behave like the number 1 does. So you multiply any number by 1, you get that number back. If you multiply any matrix by an identity matrix, you get that matrix back again. Okay, now we have to talk about inverse matrices. I'm going to show an example of one, then I'll tell you how to calculate it. All right. So here's a 2 by 2, and it's an invertible 2 by 2. I'll call it M. Okay, its inverse is this matrix. Okay, and if you multiply these in either order, either M inverse or M inverse M, it works either way. You get the identity matrix. So let's verify that. Upper left, 3, so upper row and left column. 3 times 4/10 is 1.2, right? 3 times 4 is 12, so 3 times 4/10 is 1.2. 1 times minus 0.2 is minus 0.2. So we have 1.2 minus 0.2, that's 1. Upper right, 3/10 minus 3/10, 0. Lower left, minus 8/10 plus 8/10, 0. Lower right, minus 2/10, and now we have minus times minus. So it's minus 2/10 plus 1.2. That's 1 again. Now, if you do it the other way, you get the same answer for a change, but the calculation is different. The numbers that you actually add together are not always the same as they were. And since I'm trying to keep these videos to about 15 or 20 minutes, I'll leave that for you to check. Okay, the only thing left is to explain how I arrived at this. And you need to know how to invert a 2x2 matrix. Okay, so let's see if I can do that. All right, now here's how I'll do it. Here's the procedure. To invert ABCD, and here we'll apply it to our example here. So it's 3 easy steps. If you practice this a little bit, you can do it in your head. Don't even have to write anything down. So the first thing you do is you switch A and D and change the signs of B and C. Swap A and D and change the signs B and C. So that gives us D minus B minus C and A. All right, so over here, switch these two, change the signs of these entries. Then you calculate a number I'll call E. What is it? It's AD minus BC. Going back to the original matrix. So E is 3 times negative 4 minus 1 times negative 2. Watch your signs here. So this is minus 12 minus negative 2, so that's minus 10. E has the value negative 10. And then the last step is you calculate 1 over E times step 1. Answer. So the inverse of this matrix then is 1 over minus 10 times this matrix. So what would that be? Well, when you divide by 10, you just have a decimal point all of a sudden, and then when you have the minus, it just changes the sign. So we'll have 0.4, 0.1, minus 0.2, and minus 0.3. And that's what I had up there a minute ago, right? this is the inverse of this. I'll give you one to practice. So, find the inverse of 2, 1, 6, 4. And the answer is this matrix. Okay, thank you, class. That's it for this video.